we are going to do a slicing by explicit index. Okay, so it means here you can see data for slicing. You can use this syntax. Okay, so it means that A, B, C. Here data A to C is mentioned here. So A to C means from A to C how much data will be sliced out of 5 elements. These 3 elements will be sliced from this list of series. Okay, so you can see here A, B, C. These has been sliced. So in other case, if you want to slice from B to D, you can change it. Okay, so for example, I'm going to say put here B to D. So after running this, what we will get an output, the sliced content will be from 0.50 to 1.00. Here it is. So here we got from 0.50 to 1.1. 3 parts has been sliced from this 5 entire series. Okay, this is slicing by explicit index. Okay, so another type of slicing is slicing by implicit integer index. So it means in the name itself we have got a meaning, implicit integer index. So integer index means we are going to use an integer. So index values which has been given here is A, B, C, D, E. Okay, but implicit integer index means it will be having a number. For example, this is the interval. So this index will be numbered from 0, 0, 1, 2, 3, 4. So overall from 0 to 4 it is there. 5 elements means it is 0 to 4. Okay, so when here the slicing value is 0 to 2 means what it takes, the value means here it starts from 0. 0 means first element will be 0, 1, 2. It has taken 1 and 2, only 2 parts has been sliced. Okay, so here we are going to check by changing the numbers and check the difference how it is going to slice. I'm going to give here 2 to 4. So 2 to 4 it takes 0.75 and 1.00. Okay, so it takes it has been sliced 0.75 and 1.00. Okay, next is we are going to see masking. Masking means we'll be having some range, and that range, among that range only we are going to pick it. For example, here data, so for 2 elements it is going to display 2 elements, and how it is going to, how we are going to pick it. It means, so data, it need to display 1 element. Okay, that element should be greater than 0.3. okay, so here you can see from this series 1 element, so the many elements will be available, but in a series at position 1 element only will fall before that. Okay, say for example 0.3 it means, so which element is greater than 0.3. 0.25 is smaller than 0.3. okay, and 0.50 is greater than 0.3. okay, so the next value 50 will be displayed here, and the second masking value is data which is smaller than 0.8. okay, so here you need to check which is smaller. So, smaller means 1.25 is greater, 1.00 is greater, and 1.75 is smaller, next to smaller. So this will be the next value. So here the output will be 0.50 and 0.75. These are the 2 outputs. So here you can see B and C, 0.50 and 0.75 is here. Okay, next we are going to see about the fancy indexing. So fancy indexing is nothing but directly you're going to just put the index value, which is very, very easier. Okay, so I'll just put the syntax and explain you. So here, see, you can see inside the square brackets. Okay, so inside the square brackets, you can put the index directly. So A and comma E, it means it will directly pick the values of A and E and display it. So this is called as the fancy indexing. So here you can see the A value is 0.25 and E value is 1.25, and that's it. And next we are going to see about indexers. Okay, indexers means it shows that LOC and ILOC. So if your series has an explicit integer index, an indexing operation such as data1 will use the explicit indexes, and while a slicing operations like data1 is to 3 will use the implicit Python style indexes. So next we are going to see, once again, here we entered into the indexer. Here you can see, yes, so data Python series is there. So here indexer means from A, B, C, okay, the index values are 1, 3, 5. Now you're going to see display the values. So here he created a new series. Okay, so here ABC is an index value. Sorry, yes, in 135 is an index value and ABC are the object. This is the index value and this is the object. So here you can see the index value. See, 135 is the index value and ABC is the object. Data type is object. So here we are going to now we are going to see explicit index when indexing. So for example, data 1, it means it will directly gives the output of the object A, because at index 1 A is there. Okay. So if you give data 5, it will show the object C. Okay, it is explicit index when indexing. Okay, and implicit index when slicing. It means next is we are going to see about implicit index when slicing. So here data 1 sliced with data C. It means among 3 indexed entire series, slicing happens from 1 to 3. So the output will be A and sorry, one second. Yes, output will be B and C, and the data object is the. Because of this potential confusion in the case of integer indexing, pandas provides some special indexer attributes that explicitly expose certain indexing schemes. Okay, so these are not functional methods but attributes that exposes a particular slicing interfaces to data in series. So first, lock attribute allows indexing and slicing that always refers the explicit indexing. So here you're going to see the log. So it we can check with the log function. So data dot log 1, then from this index it will show A X. You can see in previous slicing from data 1 to 3 it has sliced a wrong object. Okay, so here you can see it is supposed to be A and B, and here the output we have received is B and C. It is wrong. Okay, so how this problem can be resolved means it can be resolved by using a dot data dot log. So now you can check here, it will exactly slice from 1 and 3, 1 to 3, among 3. Okay, the output will be A and B. So for that purpose only lock will be specifically used. Okay, and then the ilock is there, ilock attribute is there. Okay, it always allows indexing and slicing that always refers the implicit Python style index. So for example, Here you can see data dot ilog1. Data dot ilog1 means it will give a. It will give p, and data dot data dot ilog 1 is to c means it will slice the next reference. Okay, upcoming next one. You can see here b and c. It is supposed to be a and b. Okay, so one guiding principle of Python code is that explicit is better than implicit. Okay, so first we have seen explicit, that is explicit nature of lock and ilock makes them helpful in maintaining clean and readable code, especially in the case of integer indexes. Uses them consistently can prevent subtle bugs due to the mixed indexing and slicing conventions. And that's it for this lecture, and more contents we can discuss in the upcoming lectures, like data frames as dictionary. In that we are going to put the tables, and in that table we are going to perform the operations like slicing. Okay, and we are going to, in data frames you can work on a two-dimensional array, which is a complex one comparing to the one-dimensional array. So follow next upcoming video lectures. Thank you very much.